Hello, guys. It's Kumar K, your favorite DSA teacher when it comes to solving hard unseen DSA problems of top tech companies, online assessment, and competitive programming problems. So, today we are going to solve a very interesting problem which was asked in DESHA online assessment today. So, what's happening is that on 12th November, many people are giving their DESHA online assessment for SD intern and full time SD role, off campus, on campus, both. So, the morning shift, this problem came in the morning shift, and whoever is going to give the disha away in the evening or night shift, all the best to them. And I also want to give you a little bit of guidance. Okay, so the thing is that the I have analyzed since the last 3 years. I have analyzed 158 online assessments questions asked in disha. Okay, I have always seen that they ask very hard questions on binary search, very hard variations of binary search on answer. In DP, they ask knapsack DP and partition DP, but not the standard DB problems. Hard unseen DB problems where the core theme is knapsack DP, partition DP. Obviously, you have to find, the multiple states, optimizations, XYZ, depending on the problem. So that's my take on the DSH online assessments. They are heavily geared towards binary search, knapsack DP, partition DP, and sometimes greedy and hashing is also involved. Okay, so if you prepare those topics, guys, nicely, then it should be very easy for you to crack the DSH online assessment. Also, one more thing, that if you are my course student and watching this video, I want to let you know that in our course, more than 100 DSHA OA video solutions are there, because I really love DSHA online assessment problems. And if you are my YouTube subscriber or YouTube LinkedIn community student, then you can check our past YouTube videos. I have uploaded 3 to 4 YouTube videos on DSHA online assessment in the last 2 to 3 years, and all those videos you will see, they are based on binary search or DP. This gives you a rough idea, and it will help you in preparing. Okay, if you know, as you now know which topics you have to focus more on. Okay, so now let's go towards the problem which was asked in morning. So yeah, always remember that in the online assessment, many times they give you a very big story. Okay, it gets a little bit, tough to analyze the, such large problem statements. But the key is, guys, that you have to stay positive even if you feel sad and depressed. Okay, after having the first look at the question, don't give up. Read the question carefully, drink some water, and read the question again, because most of the times the problem is not that difficult. It is just, you are making it difficult in your head. Actual problem is not that difficult. Okay, so now let's go to the problem. So problem is saying that minimum total max. So, given an array of n integers, your task is to partition the array into subarrays such that each subarray is of size less than or equal to k, and the sum. Okay. So, guys, given an array of size n, find the best way to partition the array such that the total sum of the maximum element of each partition is minimum possible. Condition is that each subarray should have size less than equal to k. See how complicated they make you look the question. So, they are saying that we are giving you an array. Divide the array in some parts. Each part size should be less than equal to k. Okay, that we can handle. Now do the summation of maximum elements of each of these parts. Whatever is that summation, we want that to be minimum sum possible. So what to do now? What to do? Think about that. What to do? So I will explain you it with an example. So let's say your array is 1, 2, 3, 4, 5. Okay, you want to divide this array in some parts such that each part size is less than equal to 2, because k is 2 na. It means each part should have either size 1 or size 2. So guys, this is one way to divide. See, first two numbers I put in the first part, 3 and 4 I put in the second part. Both are valid because their size is less than equal to 2. And the last number I put in the last part. So what is the maximum element of 1 and 2? 2. What is the maximum element in this part? 4. Maximum element in this part, 5. So the sum is 11. But there, guys, there is one more way to divide. What is that one more way? So if you observe carefully, You can put the 1 in the first box, 2 and 3 in the second box, and 4 and 5 in the last box. So for the first box, sum is number is 1. For the second box, the largest number is 3. For the last box, largest number is 5. Sum is coming as 9. So guys, see, 11 can also be the answer, 9 can also be the answer. Now tell me which answer will you pick up? Answer is 9 because we want the minimum sum. ऐसे एरे को डिवाइड करो कि फाइनल सम एकदम मिनिमम आ जाए. We want the minimum sum. So 9 is the answer because it is minimum. There are many more ways to divide this array. Even this partition is correct. 1, 2, 3. It is correct. Why it is correct? Actually, it is very simple to know why it is correct. Because you can see that each part is having a size less than equal to k, where k is 2. So this part is having size 1. This part also having size 1. This part also having size 1, 1, 1. So it is valid, but if you take the sum, what will happen? 1 plus 2 plus 3 plus 4 plus 5, which is 15. But we want the minimum sum. That's why 9 is correct answer. 15 is not correct. So there can be multiple ways to divide the array, okay? I want to let you know, guys, that there can be multiple ways to divide the array. You have to find that way which will give the minimum answer. So hopefully you got the gist of the problem by now. So now what to do and how to handle this? See, guys, I told you that D. Shaw loves binary search and dynamic programming. So, if you observe the constraints, you will see that the n value is very small. The k value is also small. Even the array input values are, in the range of just thousand. So, it means that you can do dynamic programming here. Okay. So, we will do partition DP. So what we have to do is that we have to divide the array in some parts. Each part size should be less than equal to k. Now do the summation of maximum element of each part. Total sum should be minimum possible. Now there will be people who do not know what is partition DP. And like if you study DP from standard places, standard DSA sheets, standard videos, you will not know what is partition DP. So do not worry. This is partition DP is a trick which is used highly in top tech companies' online assessment problems and competitive programming problems. So let me tell you what we do in partition DP. We just fix the last part of the array. Okay. So in our case, what will be DP of I? DP of I will be nothing but the best way to partition the first I elements such that the sum of the maximum elements is minimum. Okay. So I hope you got the gist of what I'm trying to say. For example, so k is equal to 2. Okay, let's assume that k is 2. So if you consider only this much part of the array, now I'm making a DP array. Okay, this is DP array, DP1, DP2, 3, 4, 5. DP of I should tell me the answer if the array was only from index 1 to I. Okay. सो गाइज आई होप आपको अंडरस्टैंडिंग लग रही है. डीपी ऑफ वन का मतलब अगर आप एरे का सिर्फ पहला एलिमेंट देखते हो उसका आंसर क्या है? डीपी वन है. अगर आप एरे के पहले दो एलिमेंट देखते हो तो उसका आंसर डीपी टू है. इफ यू चेक द फर्स्ट थ्री एलिमेंट्स ऑफ द एरे देन इट्स आंसर इज डीपी ऑफ थ्री. सो if you check the first four elements of the array, answer is dp of 4. If you check the first five elements of the array, answer is dp of 5. So for the whole array of size n, answer will be dp of n. I hope you got the idea. So even if you're a beginner in dp, you will understand this advanced partition dp concept because I am teaching you with love and care and affection. So dp of 1. So guys, use your brain and tell me what will be the answer if you only consider the first number. Guys, array is only of first number 1. So what will be the minimum sum? You have to take one number 1. So dp1, the answer will be 1. Simple. So I hope it's clear that in DP1 means you just consider the first number 1. Guys, for DP of 2, what can you do? These are the two ways to divide. Either you can keep 1 in first box, 2 in second box, or you can keep 1 and 2 in the same box. So if I try this way, what will be the sum? 1 plus 2, 3. If I try this way, what is the maximum element of this box? 2. So if I try to do the partition in first way, answer is 3. If I try to do it this way, answer is 2. 2 is minimum, so DP of 2 is 2. Now let's try to calculate DP of 3, okay? DP of 3, guys. How will you divide 1, 2 and 3? Think about it. One way is you divide like this. Another way is you divide like this. Another way is, you keep 1, 2, 3, all the numbers in the same box. If you do this way, answer will be 1 plus 3 because maximum of the last box is 3. 1 plus 3, 4. If you do it in this way, the answer will be 2 plus 3, 5. If you do in this way, the answer will be 3. But this is not valid. Why? Because you are putting three numbers in the same box and the size of the box is becoming 3. But in the question, it is given that size of each box should be less than equal to 2. So this is a valid way because here the first box size was 1, second box size was 2. And the second partition is also valid because the first box size is 2, second box size is 1. But the third way is not valid because only one box is there but its size is 3, so it is not allowed. So guys, I hope finally you got the gist that एरे को डिवाइड तो कर लिया बट मेक श्योर करना कि वो जो हर एक बॉक्स की साइज के से कम होनी चाहिए मींस ईच बॉक्स साइज कैन ओनली बी फ्रॉम 1 to k basically. Okay, I hope you got that. So these are the two options. So which one is minimum? This one is minimum. So DP of 3 is 4. Now guys, how will you calculate DP of 4? Guys, now we will use the partition DP concept. We will fix the last part. By fixing the last part, we will automatically know the answer. That's the greatness of partition DP. So you have to divide these numbers, right? One way is what, guys? One way is to put 4 in the last box. Guys, if I keep 4 in the last box, it is valid, right? Its size is 1. We can, make boxes of size 1 or 2, right? Box size should be less than equal to 2. So if I keep 4 in the last part, what is going to happen, lovely people? This box maximum plus the best answer till the third index. So one way is that you put the last number in the last box and now the answer will be 4 plus last number in the last box, and the best way to divide the first three numbers. What is the best way to divide first three numbers? DP of 3. We have already calculated that. So 4 plus DP of 3 is one of the way. Which is another way? You can keep 3 and 4 in the last box. Now what will be the answer? What is the max of 3 and 4? 4 plus 4 plus best answer for the first two numbers. These two numbers you have put in the last box. Now how will you solve the first two numbers? First two numbers is nothing but DP of 2. So maximum of this part 4 plus best answer if you divide the first two numbers is DP of 2. Which is third option? You can put the last three numbers in the last box, right? But this is not allowed. Size of the box cannot be 3. Size of the box should be less than equal to 2. It's given there. So there are two options. DP of 4 is nothing but 4 plus dp of 3, minimum of both these possibilities, right? Comma 4 plus dp of 2. So dp3 was 4, 4 plus 4 8, and dp2 is 2, 4 plus 2 6. So minimum of 8 and 6 is, guys, 6. So dp4 is 6. So guys, I hope you understood that just by fixing the last part we can get the general formula for our dynamic programming. Okay, so lovely people, let's go ahead. So dp4 is 6. Okay, correct, awesome. Now how will you calculate dp of I? This is a homework for you. What you can do is, you can fix this last part, right? If you fix this last part, what is gonna be the answer? 5 plus best way to divide the first four numbers, which is dp of 4. This is one option. Which is another option? I will take minimum of all these options. Okay, minimum of all these options. Another option is what, guys? One option is clear. I have to take minimum of all of them to make sure the sum is minimum. Another option is you put the last two numbers in the last box. So maximum of 4 and 5 is 5. 5 plus best way to divide the first three numbers such that their sum is also maximum, dp3. So guys, by analyzing the basic cases, now we can write the dp general formula. We have understood that we just have to fix the last part of the array. Okay, so in general, if I give you any array, okay, let's say I give you any array, okay, starting at index 1, and let's say we are at index I. Let's say k is also given to us. Okay, so what will be dp of I? What will be the first option? First option will be to put this number in the last box. Okay, so if you put this number in the last box, let's say this is the array. Let's say this is the array B. So this number will be B of I plus best answer till I minus 1 index. So B of I plus DPI minus 1. What will be the another option? Another option will be to put last two numbers in the last box, right? One option is clear. Another option is put these two numbers in the last box. So what will be the answer in that case? Maximum of these two numbers, right? Maximum of the numbers in the range I minus 1 till I, because this part's maximum we are going to take, right? Plus the best answer till I minus 2. Like this, guys, I will write all the possibilities and I will take the minimum of all of them and I will know the DPI. What will be the final answer? Final answer will be DP of n. DP of n means maximum sum for the array of size n. DPI means maximum sum of an array which is only till index I. Okay, so I hope that you guys got this brilliant observations. God is very important. Ram Ram. Okay, so there are C++, Java, Python codes for you people. You guys can check it out. Also, guys, in the description of this video, there is the list of all the 100 online assessments which have been asked in Dish or OA, okay, since the last 2 to 3 years. Okay, so you guys can check that out as well. Now, what is the general formula of our DP? Very simple. DPI is nothing but what? The B of I putting last number in last box plus dp of I minus 1. What is another option, guys? Max of the numbers from I to I minus 1 in the array This is nothing but guys. This will go on till where? Think about it. This will go on till where, guys? Guys, how many numbers can you put in the last box? At max, you can put k numbers only. Okay, so I will write it here also. Maximum you can put k numbers. So from index I, you can go back till I minus k plus 1. I hope that much mathematics you know. Plus dpi minus k. So minimum of all those, mean of all those possibilities is dp of I, and dpn is the final answer. Time complexity, two for loop you need to run. One will be for this dpi going from 1 to n, and then guys you again have to run a loop to put the numbers in the last box. So two for loops will be there. O of n into k solution it is. Okay, and space, it takes only O of n size space. Okay, so this is clear. And guys, the people interested in the implementation, they can go through the codes also. You can see that in the C++ code, it's done in a very simple manner. You can check it out here. Okay, so simply it is done in just a few lines of code. So this is rather an easy problem. Okay, if you know the basics of DP well. Okay, so if you go below, you can check the Java also and Python also. Like in the previous videos, you guys were telling me to link to give you the proper link of the code. So this time I've done that. Also, guys, please make sure you like the video and subscribe to our channel so I can keep on uploading these good videos for you. Also, guys, please write in the comments for which company OA you want the next video. Okay, like I have given the link to my community also in the description, so make sure you join it. And whenever you think that some interesting company OA has come, recommend me that question. I will solve it in the live YouTube video for you. All the best. I hope you guys enjoyed this session. Take care, love you all. Ram ram.